Hello friends, I welcome you in lecture number 26 on basic statistics. In lecture number 25, we have discussed about skewness. In this lecture, we are going to discuss about measures of skewness. So as we have discussed in earlier lecture that if frequency curve of a given distribution is stretched more to one side than to the other, then we can say that frequency distribution is skewed frequency distribution. So if we have a skewed frequency distribution, then we are interested in the measure of skewness or in the measure of lack of symmetry of that distribution. So for that we have measures of skewness. We have two types of measures for skewness. One type is absolute measures of skewness and second type of measures are relative measures of skewness. These absolute measures of skewness are dependent on the units which are given for the variable of given data. These relative measures of skewness are independent of units of given variable which is given in the data. So as we have discussed, if we have skewed distribution and if it is positively skewed, that is if the distribution has a longer tail on the right hand side, it is positively skewed distribution. And for positively skewed distribution, we have discussed that mean is always greater than median and median is always greater than mode. That means mean, median and mode are not coinciding or they are not equal for a positively or negatively skewed distribution. If distribution is positively skewed, mean is greater than median and median is greater than mode. And in the case of negatively skewed distribution, mean is less than median and median is less than mode. So this is reverse inequality. Mean is less than median, median is less than mode in case of negatively skewed distribution. So either for positively skewed distribution or negatively skewed distribution, mean, median and mode are not equal. So using this distances between mean and mode and mean and median, we can define the absolute measures of skewness. Similarly, if we have, suppose this is median, here we have mean and here we have mode. So as we know that median is equal to second quartile of the distribution. So if we measure this distance between third quartile and median and distance between median and first quartile, then for a skewed distribution these are also not equal. So difference between these two unequal distances can also be defined as absolute measure of skewness. So absolute measures of skewness are given by these three different formulas. If we consider the distance between mean and mode, then also it is absolute measure of skewness. Similarly, distance between mean and median is also defined as a measure of skewness. And similarly, distance between third quartile and median and distance between first quartile and median, and difference of these two distances is Q3 plus Q1 minus 2 times median. So these are the three absolute measures of skewness. And here we assume that our distribution is unimodal, that is it has only one mode, and sometimes mode is undefined. So in that case we can use this absolute measure mean minus median, or we can use this one also. But absolute measures of skewness are generally not of much practical utility because they involve the units of measurement. So if these measures of skewness are dependent on units, then we cannot compare two data which are expressed in terms of different units. So for that we require some another measure of skewness which is independent of units. So those type of measures are known as relative measures of skewness. For comparing two or more distributions for skewness, we compute the relative measures of skewness, and relative measures of skewness are commonly known as coefficients of skewness. Coefficients of skewness are relative measures of skewness, and they are always independent of units. So if we want to compare two or more data sets, we can use coefficients of skewness for the comparison. So there are different relative measures of skewness. First one is given by this Karl Pearson. Therefore it is known as Karl Pearson's coefficient of skewness. So it is defined as coefficient of skewness equal to distance between mean and mode divided by standard deviation. So here also we have assumption that our frequency distribution is unimodal and it is asymmetric, so that mean and mode will not coincide, and we also assume that mode is defined for a given frequency distribution. So under these assumptions we can calculate Karl Pearson's coefficient of skewness by this formula. It is ratio of mean minus mode and standard deviation. Now sometimes if mode is not defined properly, or if it is not possible to locate the mode of a given frequency distribution, then we can use the relationship between mean and mode, mean and median. So we can express this coefficient of skewness in terms of mean and median also. For that we recall the relationship between mean, median and mode. We know that mode is given by 3 times median minus 2 times mean. This is the empirical relationship between mean, median and mode for moderately asymmetric distribution. So we can use this relationship. We can replace this mode by 3 times median minus 2 times mean, and we can obtain the formula of coefficient of skewness in terms of mean and median. So if mode of a data is indeterminate or ill-defined, above formula does not work. In this situation we use the following empirical relationship between the mean, median and mode for a moderately asymmetrical distribution. Mode equal to 3 times median minus 2 times mean. So we use this relationship in equation 1. We replace mode by 3 times median minus 2 times mean, and we obtain coefficient of skewness as mean minus 3 times median minus 2 times mean. This we write in place of mode divided by standard deviation, and if we take this negative sign inside the bracket, here we will have 2 times mean, and there is 1 time mean already. So there will be 3 times mean minus 3 times median, and we can take 3 common. So we will have 3 times mean minus median divided by standard deviation. So either we can use this coefficient of skewness which uses mean and mode. It is given by mean minus mode divided by standard deviation, or we can use this coefficient of skewness 3 times mean minus median divided by standard deviation. Now this coefficient of skewness, if value of this coefficient which we calculate is between minus 0.5 and 0.5, then we can say that distribution is nearly symmetrical. If the skewness lies between minus 0.5 and 0.5, then we can say that distribution is nearly symmetrical. Okay, so we can have this type of situation, minus 0.5, 0.5, then I will have 1, here I will have minus 1. So if we obtain the value of skewness in this range, between minus 0.5 to 0.5, then we can say that given distribution is nearly symmetrical. But suppose value of skewness or coefficient of skewness is in between minus 1 and 0.5 or in between 0.5 and 1, then we can say that distribution is slightly skewed. Now if value is in between 0.5 and 1, we can say that it is positively skewed, and if value is in between minus 1 and minus 0.5, then it is negatively skewed. Now if distribution has coefficient of skewness which is greater than 1 or less than minus 1, then we can say that distribution is highly skewed. And the value of coefficient of skewness lies between minus 3 and 3. So theoretically, coefficient of skewness has boundaries minus 3 and 3. Coefficient of skewness lies between minus 3 and 3. So as I discussed, if the skewness is between minus 0.5 and 0.5, the data are nearly symmetrical. If the skewness is between minus 1 and minus 0.5 or between 0.5 and 1, data are slightly skewed. Okay, so as I discussed, if distribution is in between minus 1 and minus 0.5, then it is negatively skewed. If it is in between 0.5 and 1, then it is positively skewed. And if the skewness is lower than minus 1, that is in this part, or greater than 1, then the data are highly skewed or extremely skewed. So we will remember all these details about coefficient of skewness. We have defined Karl Pearson's coefficient of skewness, and it is given by mean minus mode over standard deviation, or it is given by 3 times mean minus mode over standard deviation. So this is the first measure of coefficient of skewness. It is given by Karl Pearson. So in the next lecture we will discuss examples on Karl Pearson's coefficient of skewness. So this is all about this session. I hope you like it. Thank you very much.